dive in. So knowledge graphs. So here's how I wanted us to start off with this. This is not new. We're hearing a lot about knowledge graphs recently, but it's pretty old. And I think I wrote this paper back in 2021, which actually goes through the historical overview of all the things that have happened in computer science since like the 50s, like called modern computer science, that have led to what we call a knowledge graph. Now we talk about, let's jump. You have ChatGPT comes out November 2022. And during that time, right after, I think during that Christmas and December and January, everybody was like spending time testing this out. And when you were starting to go see, everybody was saying, oh, we can now generate SQL and we can go chat with our data and all that stuff. Remember, also remind yourself, generating text to SQL is not a new thing. This has been, people have been working on this for like 30 plus years. So again, by the way, I love history and I really, really push people to read history because the reason why I just get so annoyed people reinvent the wheel and they think they're doing the latest, greatest stuff, but you're really not. You should be reading the wheel, reading the past so you don't reinvent the wheel, or reinvent it, make it better. So what happened was that, think about January, you start seeing a bunch of people talking about doing all these blog posts of how, yes, you can generate SQL, but I would call this that it was really all about cute examples, cute ideas, cute queries, cute tables and columns and so forth. And it wasn't enough. So we really put out, there was actually, at the Snowflake Summit, I think in the summer 2023, we were talking to a lot of folks over at Snowflake and we're like, okay, there needs to be the semantics. There needs to be all this context. How are you going to go past that? And they actually challenged us. They said, well, what does that look like? Like, we get that you need knowledge graphs, and we've already started to talk about this, but what does it actually look like? So we started doing all this research, and we did this benchmark report that we put out. And about if you start putting knowledge graphs, you do question answering using knowledge graphs, comparing that to answering questions directly over your SQL database. And the result from that was that by putting knowledge graphs was like 3 times more accurate. That was a talk that I gave last year here at Data Insight. Then GraphRag kicks off after that. And then we did further work on this, and kind of that 3x got up to like 4x now with more stuff that we did. And then the GraphRag manifesto comes around after. So just to kind of highlight why we're seeing so much knowledge graphs out of this, this was the experiment that we did early on. It's over now 2 years old. So we took a simple zero-shot prompt. Literally, it's this. Following is your SQL DDL. Copy and paste. Write the following SQL query for the question. That's kind of the little high-level architecture. Now, on the right-hand side, what we did is the following is your OWL ontology. Right? We'll talk about OWL and ontology stuff in a second, but this is your graph model. It's maybe if you haven't heard about OWL, guess what? OWL is a standard, a web standard that has been out there for over 20 years. What have LLMs been trained on? The web. So they actually know these standards very well. They know RDF, they know Sparkle. If you don't know about this stuff, the LLMs do know about it. And we did the exact same thing. Here's the OWL ontology internal syntax. Write the SQL query, write a Sparkle query for the following question. In this particular example, in the setup that we did, we had a virtualized knowledge graph. So it was taking the Sparkle query and then translated to SQL using these mappings. We'll talk about it in a second. This could have been a materialized knowledge graph, but that was what we were testing. And the result, it was 3 times more accurate by this very simple setup. And on purposely, we wanted to do something super simple. And then that just kicked off. That work blew off, right? It blew up, and then everybody started kind of replicating this. And we had so many different other semantic layer vendors and different tools saying, look, here's the evidence. We actually have evidence that knowledge graph actually improves the accuracy for LLM, right? So actually the GraphRag manifesto from Neo4j really cites the work that we presented here of why knowledge graph is important for LLM. So point being, this has been increasing now. AI, LLMs, generative AI have been pushing kind of for knowledge graph. That's what we're seeing this, even though it's pretty old. This was actually at the Gartner Data Analytics London. Love or hate Gartner, whatever, I don't care what you guys think about. This is pretty cool. Top 10 trends in data integration, data engineering. Number 6 was adding semantic data integration and knowledge. So if you're not doing it, you're behind, because the leaders and your competitors in your space are probably doing it. So time to learn. Okay, but here's the problem now. Everybody has a freaking semantic layer. Everybody. This is just, now it's just way too much marketing, Mike. So let's actually start with definition. Business glossary. What is a business glossary, right? It's just a list of business terms that we want to be able to have to start generating some alignment across different teams. Remember yesterday I was talking about governance and that A active as alignment. The first thing you should be starting off with is a set of business terms, business glossary around that stuff. So if you don't even have that, where you should go. The next step is to actually start getting into what we're calling controlled vocabulary, right? Let's actually have some set of fixed definitions, right? Where we actually have agreement and there's not going to be any more ambiguity around things. It can be things like reference data, right? You do even your set of geographies, stuff like that. Here's your statuses, right? These are some controlled vocabulary. But before, if you don't have that, you should probably have a business glossary first. You see how you have like the spectrum around that. Now we start hearing more about these semantic layers. And the term semantic layer that we hear about today, I put here BI kind of in parentheses, is because they're usually connected to business intelligence. They're usually saying, look, we want to be able to provide this clear, this business view of using the business concepts. Therefore, you should have already defined this beforehand in your business glossaries and then have control vocabularies before you jump into your semantic layers. People are jumping to this now, but they don't have their business terminology defined. So then you're just skipping steps. So, and a lot of these semantic layers are about defining what are your dimensions and what are your measures, what are your metrics. So they're very specific to BI. But semantics is not just for BI. We have for all the generative AI, for any type of applications you want to go build that needs to have this clear understanding. Now I want to go into taxonomies. Right? So now we're actually talking about a relationship between different concepts, and usually that relationship is going to be more about hierarchical relationships. It can be broader than or narrower than relationships. It can be subclass relationships, right? Then once you get to taxonomy, so again, this is how we start building up kind of more and more of the semantics and meaning of things. Now we start getting into ontology. And this is where we start defining the concepts, the relationships between the different concepts, and then which are not just parent-child relationships. They can be any type of, like the previous example, right? Orders and customers and products and so forth. And or a customer purchases an order, but then you can start adding more axioms or more rules around that. Cardinality constraints, right? A customer can purchase multiple orders. An order can only be purchased by one customer. And then when we keep going this is how we start getting into knowledge graphs. And this is actually just kind of a screenshot from my book. Again, connect with me on LinkedIn, and I'll just send you a copy of my book. I want to give you my definition of random stuff. So a knowledge graph is a collection of real-world concepts, represented as nodes, and relationships in the form of a graph. And you want to use this to integrate data coming from multiple sources. In the previous talk, you actually showed that. And you can take tabular data, tables from relational database, and you can represent that as a graph. If you take tree-like structures like XML or JSON, you can represent that also as a graph. If you do NLP, entity extraction, relationship extraction, you can represent that as a graph. So graph is always that really very common denominator across all these different types of data models. Knowledge is the meaning part, is where you actually start defining, remember that meaning, the business glossary, the control vocabularies, the taxonomies, the ontologies. That's the knowledge part. And then graph is that structure about nodes and edges. And what I really wanted to highlight is this thing here. The term knowledge graph was coined and popularized by Google in 2012. But all of this work comes from from a lot of the semantic web world. So we're going to talk about things like RDF and OWL. These are standards that have been defined by the W3C, and all of this stuff has been implemented, followed by Google. And when people start kind of arguing, like, what is this definition of knowledge graph and so forth, I'm like, look, you're really trying to define what a marketing team wrote in a blog post as well. So let's calm down. And then again, if you want to know more about this history, you can just look up this paper we have here, which really goes into what's really fascinating. The history is that over time, we have, I like to call it, we've had this two parallels of the knowledge world and the data world. And over the last 60, 70 years, we've seen them kind of come together, separate, come together, and separate. So actually, what was the first database? It was a hierarchical, it was a network database. It was a graph database, right? And what happened over there was that things were very tightly coupled. And then the relational database, relation model comes around with COD, is that they want to have this independence, and they start separating from that. And then you have in the 80s, you have things about like object-oriented programming and object-oriented databases. So they're trying to plug those stuff together. And you have things like deductive databases and data log coming around. And then you have expert systems trying to go, they separate because you're focusing too much on, start focusing a lot more on the knowledge representation. But you see this historically coming up and down. But these ideas have always been the same. Like semantic networks is something from the 60s. So what I just described is actually, I mean, historically it's called the ontology spectrum. I think Jessica Townsend is calling that the ontology pipeline now. There was actually a big meeting in the AAAI conference in 1999 where all these people got together and saying, what does this actually mean and how we put it all together? It's kind of that's coming from. So again, this isn't new. That's the point. Everybody's understanding. And then there's all these standards when it comes to the semantics, right? So RDF. So raise your hand if you've heard about RDF? Oh, that's lovely. So RDF comes from the web community. So Aurel, Asila, and company did the first version of RDF in 1998. 98. It was a way to describe metadata about web pages. So it's like you have a web page. And by the way, the web. By the way, this is my other pet peeve. When you say the internet, you really mean the web, not the internet. The web was Tim Berners-Lee. That's where you go. Like 1989 was created. That's what we mean when you go to your phone and your browser. That's the web. It's built on top of the internet. Sid Cerf is the father of the internet. Tim Berners-Lee is the father of it. So the web itself is a graph, right? You have a page and you click on a link, which takes you to another page. And RDF is just basically following that same mechanism, but more at a more granular level, the data. So you can start adding metadata around stuff. Follow the link, though. So that's what RDF. It's a triple representation. Then you have things like SCOS. SCOS is the Simple Knowledge Organizational System. So it's a way of representing business glossaries and taxonomy. OWL is a way of representing ontology languages and semantic layers. Shackle is a way of defining constraints. Provo is a way of representing provenance, lineage. DCAT is the data catalog vocabulary. There's a bunch of other standards that would already have been defined for managing metadata. So yesterday when I was on the panel, or I was talking about the open source, I'm like, there's also this need for interoperability of metadata. And I know everybody's going off and probably thinking about, there's all these different new semantic layers, and I'm like, there's going to be all this competition now, different ways of interoperating metadata. But this stuff is already there. Like, let's not reinvent the wheel. My call out. If you've not been paying attention to this stuff, this is the opportunity right now. Let's focus our energy on new things and not reinventing the wheel. So something I always posit is that your first knowledge graph should really be about metadata. So let's go through an example right here. So this is the standard TPCH schema, right? See, you have customers, there's order lines, there's orders, right? Kind of typical stuff. Simple example, but bear with me. So what I'm going to go through is that we're going to start actually building the metadata knowledge graph. I'm going to start showing you all RDF triple. I'm going to show you code in here, but I think my point is if you've never seen it, probably you're going to look at it and like, but then hopefully you'll realize it's not that complicated. And okay, let's walk through this. This is RDF. This is a serialization of your RDF of your knowledge graph right now in RDF, and you can see that I have start off here. Like there's this thing that I'm calling on a TPCH database. the database has an identifier, that's the name of the database. There is a schema, which is part of that database. There's a table, which is part of that schema, and it has these primary key columns. Order key is a column, it's part of that table. There's a bunch of other columns that are part of that table, right? So pretty simple representing that. So actually, when you think about it, when you have a data catalog that manages your metadata about your different systems, like what you're really doing is that you're extracting your metadata and you're effectively representing this underneath. So, okay, this is syntax. By the way, this is literally RDF in the syntax. Like you can drop these strings, load it into an RDF database, and it's there. You can now store it and access it, query it. But let's actually visualize it for a second, right? So there was that table that I have here, and this is that column is part of that. I didn't write the part of here just to kind of keep it simple, the image, but now that's that visualization. This is what I'm calling the technical metadata. All of this is generated automatically, right? I can extract that automatically from any source. All right, now let's jump into the business metadata. And this is kind of where the people in the process part comes in, right? So let's go talk to the people. Remember my talk yesterday? You start having that methodology, that pay-as-you-go methodology. That first step, you're trying to understand what the question is and trying to talk to people what these things mean. And that process is how you're defining what those terms are and what they mean, right? You first should be describing that as a business glossary. All right, here are my terms: order line item, order line quantity, extended price, discount, net revenue. And then what I can start doing is I should first list this out as a business glossary, and then I can start kind of organizing this more into that ontology. And I can say, order line item, that is a class, that's a concept, and I have this definition for it. Quantity, that is a data type property. That data type property has a label and also has an alternative label, synonyms. And I can say that quantity has a domain, which is an order line item. It means that quantity is part of an order line item, and it is expecting the range, it's expecting integers. Extended price is also a property, has different labels, and then alternative labels, definitions, and it's part of the order line item. So forth. Keep doing this. Now I'm actually turning that business glossary, it should first start out as being text, right? Probably stored in the spreadsheet, whatever. But here I'm actually starting to codify it. Right now this is code. Store this, I can manage it, I can govern it. Also represented as a graph, right? In this case, I'm showing here's that concept order line, and here are the properties that are associated to that order line. So now you're saying I talk about business metadata and the technical metadata. How do I connect this stuff together? So I'm going to say that in this particular example, that table called line item actually maps to the concept of order line item. And so it basically says like every single instance, every single row of that table actually represent in reality what an order line item is. If I were to say, how many order line items do we have? It's the equivalent of counting how many rows I have in that. And how do I say that these two things are the same or they're related? Literally, I just add another triple, a connection there. I'm going to say that this column called quantity actually represents what the quantity is. So, but hey, this is like simple one-to-one mapping. But hey, life isn't simple. So what does net revenue mean? Well, there was no column in your database called net revenue. And net revenue actually has a very specific definition. We actually described it in English in this particular example over here, right? The net extended price of the order line after discount but before tax. What does that actually mean? Well, here's the meaning of it. We're saying, look, net revenue has this formula. Here's the column multiplied by this, right? This is already some SQL expression. And I'm actually being very explicit. I'm saying this definition of net revenue is calculating its values from these particular two columns. It's part of that table, and it's going to map to that property that I have called net revenue. So if I put this all together now, I'm saying, hey, this column is maps to that. These two are all simple one-to-one mappings, but I'm actually defining this new kind of concept here called a net revenue column, which I'm mapping to this business metadata for net revenue, and I'm saying it calculates values from these two different concepts. And that's what we're calling our mapping metadata. So when we think about metadata, I really want us to separate. There's technical metadata. This is the observations of the world. This is just facts of life. You cannot deny this because that's what exists in the database. I'm just saying that that's what it is. This is the different interpretations. By the way, this could be the business metadata interpretation of the finance domain. And there could be another net revenue from the marketing domain, and we just know that they're different things, but that's the inspiration. That's how they're being defined. And the mapping metadata is what's connecting that business metadata and that technical metadata. I think what happens today is that this all gets kind of jumbled into some DBT code or some queries or some stored procedures, and it gets lost. And what we do with data catalogs is that we try to reverse engineer this. But I think you go back to what I was presenting yesterday, we do the whole pay-as-you-go and do that iron thread approach. You should be able to define this entire process. Okay, so, but what does semantics actually mean? Right, we're talking about semantics. My definition of semantics is the business plus the mapping plus the technical metadata. Because when I say, what does net revenue mean? I'm like, oh, net revenue is part of an order line item, and this definition of net revenue actually means there is this new column that is being defined, net revenue, which calculates values from extended price and discount price inside this, right? There was that calculation, right? That formula, and it's used part of this particular table. That's what net revenue means. And we codify it. That's a semantics. So when I define that, let's say, here's an input. Here's that particular table, that line item table, this is the actual table. And now I have defined that semantic. With that semantics, I can do so much stuff. I want to deploy that semantics into some semantic layer such that I can build a very nice, beautiful table. In this case, look, that beautiful table has actually the nice words. It has it has this new column, net revenue, which didn't exist before. If you do the math, that should actually be the thing that we defined in there. I want to build a knowledge graph. This case is an example in RDF. It could be a cipher, or it could be something Neo4j. And I want to write now, this is Sparkle. This is the graph query language for RDF. Or you know what? I actually want to have some chatbot or some LLM be able to go do some RAG or whatever to be able to ask questions about my metadata by business. Hey, what is net revenue? Oh, net revenue is the line item is defined, well, that was the business description. I get all of this other context, right, that comes from that mapping metadata. So you define that semantics once, you can reuse it over and over in so many different places. Like this semantic layer could be your Power BI semantic model and your Snowflake Cortex thing, and then the one we saw yesterday, Malloy. Like you should be able to take all of that semantics to define and deploy it in so many multiple systems. Nobody should stop. Nobody should stop you. You should be able to enable that. And that's what I mean by this deployment. So you take the semantics, that what I'm calling that governed metadata, the whole 3 layers. You need to be governing that. Go back to my talk yesterday. You're going to go have this whole process and build this little by little. Actually, in the coffee earlier, I was talking to Andrew, and I was saying that the way you can go this governed metadata, I talk about it as a fixed, flexible, and custom. So there are things that you want to govern that's fixed. Here's how you go do this. You define it, you go reuse it. Flexible is that stuff is there, but I have something new. I'm going to reuse what I have it to build my new thing. And custom is I'm starting from scratch. So when I have this governed metadata, I actually can deploy that, and I can then use this metadata to create my knowledge graphs in RDF or in Neo4j. I can deploy that in any semantic layer like Malloy or Cube or whatever you have. In Power BI, Power BI has semantic models and so forth, right? All the data cloud providers, Snowflake has now their Cortex YAML and so forth. You want to build schemas out of this, you can produce that, right? Basically any tool that needs to consume context to be consuming that from your semantics, your government. Here's an example, like everything that I just defined in that knowledge graph, in that graph, this was the result of turning that into the Cortex semantic model. And here's another standard called R2RML. I actually worked on this standard like 15 years ago, which is how to map relational databases to RDF. The exact same semantics represented in R2RML such that you can now map your relational database and turn it into an RDF graph. Now, the power here about semantics is that it's reusability. And I think this is something that I want to highlight more, because this is truly the power of the 1 + 1 is greater than 2, right? We want to eliminate redundant logic, right? We should not have to redefine net revenue over and over again, right? Some people define it in your Power BI dashboard. Some people define it in your ETL code, in your Python script, and so forth. It reduces that risk, right? Then if you update the definition of net revenue, where is that defined? The foundations of scale is like, I want to be able to reuse that, because I don't want to spend more time redefining that stuff over and over again. Explainability, right? I want to understand, what does net revenue mean? And like, oh, well, here's a definition. By the way, in that graph, I could have added a bunch more, like who was the person who actually defined that? When was the last time it was reviewed to make sure that was actually the right thing? So let's continue the example, and I say, hey, let's say, what is total profit? Okay, total profit, after talking to people, whatever, we say it's net revenue minus the cost. Net revenue, perfect, I got that. I don't need to redefine that. What is cost? Oh, it's supply cost times the quantity. I need to get that from 2 different tables. So let's keep adding to that. So total profit. Oh, I need to find cost. So I'm going to say there's a cost to the line item. So I'm just adding this new property, still associated with that same concept, the domain of order line item. And then total profit. I'm saying total profit is a metric. It's gonna aggregate over everything that's an order line. It's gonna really depend on these 2 columns. And that's a formula around that. So that's the business metadata. So all I'm doing here is adding that new property, a new thing called total profit that is aggregated over the order line item, and it's related to the net revenue and the cost. And this actually is the business definition of this. So now I need to bring in a couple more columns, right? I need to bring in the table part supplier, and that has a supplier cost. All right, that's there. Now we got to do the mapping. Oof, okay, let's see. By the way, this seems complex, but this is just the reality of your business. So I'm not making things more complex than it needs to be. This is just how your business works. So what is the cost is actually you take the supply cost and you multiply that by the quantity, right? So I'm calculating those values from these 2 different columns. And the way I calculate that is from some query, because I have to do a join. I have to join across the line item left join with the part supplier, which also is calculating stuff from those 2 tables. And I have to define what that metric is for total profit, is that I want to actually do the sum over net revenue and line item cost. This is a lot of code in here, but how this visually looks like, so I have this new concept called the cost column, which calculates values from the quantity and the supply. But this thing itself depends on a new query that is joining from these 2 different tables. And this profit, which maps the total profit here, is actually using the values from net revenue column. And you see that this is now reusing all of this work over here. Look, this may seem complex, but again, this is just the reality of your business. And what we try to do with metadata tools and so forth is to reverse engineer the stuff that you already have, and you're going to find a big mess of that stuff. This is why people want to go to see the lineage, and then they complain that the lineage is so blah, right? I mean, they're like, well, that's because that's the reality of what people did in that business. Now, if you go through that whole process I described yesterday, you have your minimal valuable governance. You go through your pay-as-you-go methodology. You start building this bottoms up, top down, right? And then this is the lineage. This is your lineage right there. So, but what I find incredibly exciting is that we're talking here about technical metadata, business metadata, and kind of things, even for like in the data analytics space. But this is what I was describing as your metadata graph. So let's say you have your database, and I have tables are part of a database, and I have a dashboard. I have my business terminology like orders, I have ARR, which is a metric. I know that this table is related to that concept, and this metric is related to the order, and this dashboard is related to that metric, and that dashboard was derived from that table, which was derived from that table. This is what you have in your typical data catalog, your metadata catalog, which just does things for like extracting metadata for tables and columns and dashboards and your ETL and stuff. But you should expand that. This should be more than, you should say, I should track people. Like Ray, Ruben is the steward of that database. And Sally was the analyst who produced that report. And you can just keep tracking of your ontologies, your business glossaries. Orders are placed by customers, and customer purchases products, right? That's your data models are part of this. By the way, Ruben works in the data department, Sally works in the sales department, and then Alice is the VP in the sales department. And Alice is actually, and there's a whole pricing business process about how we do things. And Alice is the owner of this business process. And that net sales table is the data from the net sales table impacts that business process, and that business process for pricing impacts to how the product is doing. All of this is what you should, your catalog, or this is what your knowledge graph should be doing. By the way, Bob is a customer, Alice is a customer, ABC is a product, XYZ is a product, Bob purchased this product, and so forth. Like, that is how I'm starting to go build the enterprise brain of my organization. Like, all of this should be accessible. Like, I think this is the vision. This is where we should be heading. And it starts from your technical metadata, your business metadata, your mapping metadata, you're bringing your business processes, bring in all the instances. With this, we actually are starting to understand what our business does, so we can ask so many more questions. We can figure out how we can improve our operations. We can find bottlenecks, so forth. So that enterprise brain, kind of just to wrap up here, I know I'm kind of hitting time. Actually, I think I'm still got 7 more minutes, or am I over time? I don't know. I thought it was still 4:40. Anyways, I'm gonna wrap it up. So the way to see this is that at the top level, you have all these business problems that you're solving. At the source, right? This is all the data that you're trying to go use. This enterprise brain is what you're building. And I think at this level here is this orchestration. And this is kind of a reference architecture. We've been working with customers for a while. It was actually before MCP. The enterprise brain is your library. You walk into the library. When was the last time somebody went to the library? That's sad. You go to the library. I have kids now. I go more to the library. So you go to the library, and if you walk into the library, you know what you're looking for, you can self-service, right? You can go walk in, and the reason why you can find things is because it's really nice organized, right? Dewey Decimal Systems, it has semantics, meaning you can go find things. But sometimes you may not know what you're looking for, you need some help. So where do? You go to the reference desk, the reference librarian, and you ask, hey, I'm looking for this thing and that thing, and they'll ask questions and try to get your information needs, and they say, oh, here, we'll help you. That's the orchestration around that. So I'm not going to go through this, but this is just an idea to show you that this whole brain part is divided by the left and the right, the metadata, the knowledge part, and the data part. And then you have the governance we were talking about yesterday. That is your enterprise brain. So I talked about this quickly yesterday. You want to look at ontologies, how people do it, look at schema.org. This is an example. S&P Global, just really quickly to wrap up on this. What does AI-ready data mean? S&P Global has a very specific answer. They create a knowledge graph. Every single entity they have around what is units, for example, Celsius, Fahrenheit, how many gallons of barrels or whatever they have. And every single column of data is connected. You don't just know that this data type is integer, or it's a float or whatever. It's actually a Fahrenheit. So for them, AI-ready data is every single column is connected to a particular concept or attribute in a knowledge graph. So, takeaways. What is semantics? It's business, mapping, and technical data together. That is your governed metadata. Semantics is your governed metadata. That you should define it once, govern it, and reuse it everywhere. And knowledge graphs, think about it as the way of building your enterprise brain of your organization. Thank you very much.